Hey guys, what's up? My name is Gabe and this is Games with Gabe. This is the next episode in the Coding Geometry Dash in Java series. So in this episode, we are going to get to box triggers, making box colliders that are just triggers so that you can trigger events with them. And then we will also be working on using those triggers to create portals or create box-shaped like spike-like objects that will kill you and doing things like that. So that's what we're going to get to in this tutorial, and then in the next tutorial what we're going to be doing is the final phase, which is just some odds and ends that we just haven't covered yet, like smaller triangles and smaller boxes and stuff, getting the fine-tuning done on those types of things. But in this one, what we will be doing is just those box triggers. So let's just code the box triggers real quick. They're pretty simple conceptually. It's basically the exact same thing as the box collider, except we don't resolve the collision. And then using it to do different things, we just check and see if it was triggered. And then we do whatever we want to do with it. So let's code that up real quick. Shouldn't be too difficult, and let's see how it works. Alright guys, so in the last tutorial we were doing some level editor stuff where now we can place in some blocks, select, multi-select, move them all around, we can delete them, do all this different stuff. That's what we basically did in the last tutorial. In this tutorial what we're going to be doing is creating that box trigger effect, which is actually pretty simple because we have most of the work done. We just have to change up a few things and add a new function, and then we have the work completely done. So let's first go into our components and we'll go into our box bound. And then we're going to add a new function in here called, we'll just use this check collision function, and then we'll add a couple of modifications. First of all, though, what we might want to do is we'll add in a Boolean variable up here. So we'll say Boolean is trigger. This will make it so that we don't resolve any collisions with a trigger box. So we will initialize this to false. Actually, let's just do this, and this is what I've been doing lately, is creating a init function. So we'll say void init, and this will take in the width, the height, and then a Boolean is trigger. Then what we'll do is we'll copy and paste all of this stuff, put it in here, and then we'll just say init this with width, height, and this is not a trigger. So basically, we're just going to overload the constructor and use this init function to do all the work for us. And then we'll do float width and float height, and Boolean is trigger. And then, so this is if the user of this class wanted to create a function or a box bound that had a trigger, then we would just do this. And we'd say init width, height, and is trigger. And then lastly, inside this init is init. This init function, we want to set is trigger to the variable they passed in. Okay, so now we have this is trigger variable. Another thing we might want to do, which we'll probably look into, because I don't know if we would want to do it in here or outside, is for boxes that kill the player. But we have this is trigger variable, and then what we can do now is inside resolve collision, we can say if is trigger, then return. We just don't resolve any collisions for trigger boxes. We check the collisions, we just don't resolve the collisions. Next, let's go into our menu, because this is where we actually create all the items. So inside menu item, we have, or actually inside main container is where we create all the items. We have this big for loop where we're creating everything. And this basically loops through and adds every single object for every single tab. So if we go down here, it says add second tab, add fourth tab. So we added the triangle bounds here. That's good. And then let's go to where we have the portals. So I believe that's the last tab. Yep, create portal component here. So while we're creating the box bounds, let's also say this is a trigger. So we'll set that to true. And now if we place in a portal, and we'll go down here and hit the portal. If we place in a couple portals, the player should just go through them. It shouldn't kill the player. Hit F1 to save that, and then F3 to play. And the player is getting killed. And the problem actually resides inside of our copy method. We just need to add in is trigger to this copy method. So don't forget that. That could lead to some problems. And then also our serialization and deserialization. We should add this is trigger to these two components too. So down here we'll say builder.append, add Boolean property, and this is going to be is trigger. We'll say this dot is trigger, tab size +1. new line, true, comma, false, and then go up here, change this comma to a true since we have a parameter after it. And then in our deserialize method, what we'll do is we'll just say parser.consume a comma, and we'll say parser.consume boolean property is trigger, and then we'll just move this line down to here, and we should be good. And then we'll return new box bounds with is trigger as part of this. So go up here and then say boolean is trigger equals this, and we'll just add it down here. So we just fix up our serialization method, adding in the serialization for this parameter and deserialization. So that was the problem. We didn't quite have that, and we didn't quite have it in the copy method. So F1 to save it, F3 to play. There we go. Now we get it working properly. So now we have the ability to trigger box collisions, and we can check and see that this is triggering by actually going up to here, and we'll say system.out.println here. And if we notice as the player goes through these objects, you'll see it prints out here down here. So we are still triggering them, we just aren't resolving them, which is good because that's exactly what we want for what we're going to do. So next thing we want to do, let's build the portal component, because this will probably be easiest to illustrate how we can use this if we actually build the portal component. So we'll say portal, and we'll add this, and then we'll say this extends component, and we will import this class, and then we will implement the methods. So for copy, we'll just say return new portal, and we're probably going to have a few different things, and then we'll implement that serialize and deserialize method in just a second. So what do we need for a portal class? Well, we need the state that we want this to change the player to. What is a state? Well, a state is anything like flying or normal, or triangle, the triangle state that the player has, or it could be the robot state. These are all the different states, and so these are things we would store inside, not in the portal, because it doesn't really make sense. It's not a state of the portal, it's a state of the player. So if we go to the player, we could let's actually create a new enum in here. So we'll go and we'll say create an enum player state. So I don't know if components is the best package to have this, but we'll put it in here regardless. So we'll have a normal state for now and a flying state. So we have these two states, and then we'll go to the player, and we will have a public player state, the state. So this is going to be the state the player is currently in, which defaults to, if we go into here, state, we'll say this dot state equals player state dot normal. So we'll default it to normal. The player is automatically in the normal state, and then we will implement a flying state. So let's go into our portal class, and this guy will take in, he will have a public player state changer. So this is what the portal changes the player state to. So then when we create a portal, we'll have a player state as the input parameter, and this will be the state changer. And we'll take that in, and then we'll just say state changer equals this state changer. And then next, we will pass that into here too for our copy method, of course. And inside of our update method, we can check and see if the player is colliding with this. So we'll implement that update method, and then we will check and see if the player is triggering the box bounds attached to this portal. And if it is, then we can check and see if then we can change the player state. So let's actually take in the player object too. This would make sense. We'll take in player, player. Well, not the player component, but game object, player. And then we will take in a reference to the player here. So we'll say game object player here, and then we'll just say this.player equals player. And that should be good. We could move this to our start function. So if we had like public void start, and then we could implement a new function that finds a game object and stuff by name. I think this is probably fine. We'll just take it in as a parameter. And then down here, we'll also just pass in the player reference. We don't want to copy the player, we just want to pass in the reference. Up here, we'll actually store a reference to the box bounds too. So we'll say private box bounds, and we'll say This one we will have to do in the start method. So we'll say at override public void start. And then we'll say this dot bounds equals game object dot get component bounds box bounds dot class. So we'll just implement that real quick. And then down here we can say if box bounds dot check collision, we'll give it bounds, and then we will give it player dot get component box bounds dot class. So if the player and this box bounds are colliding, then we want to say, first of all, we'll print the line just to make sure this is working. Portal change, and then we'll say player dot get component player dot class dot state equals, and then we will do a state changer. So we'll change the player state to whatever state this portal is supposed to switch it to. And then let's add in one more caveat up here. We'll say if player dot get component player dot class dot state does not equal the state changer. So this way we will only trigger this portal once while we're changing the state, and then after the player changes states, it will not trigger again. So this will say portal change, and then it will be done. Let's go back into our main container, and we'll add in the portal component now. So we'll say obj.add component, and for now we'll just do a standard portal. We'll say portal, and the state changer is going to be player state dot flying, and then player. Let's just change this up. Instead of taking a player reference, we'll just get the player inside the update method, which may not be the fastest, but it should be fine. So let's go back into our portal class real quick. And then instead of saying taking a player reference here, we'll delete this part. And then we'll take this out. And inside of the update loop, we can just say, or actually we'll do it inside the start loop. We'll say level scene equals window dot get current scene or dot get scene, and then we'll just say and we'll cast this to a level scene real quick. There we go. And then if level scene or if scene does not equal null, so that means we had a successful cast, then we'll just say this dot player equals scene dot player. All right, so just a little bit simpler. No sense passing it in as a reference and stuff. Makes it a little bit easier. And then we can just do the same thing in here. For our copy method, we'll just copy this. It's probably a good idea to pass the player reference in the copy method. And so then what we'll do, because copy doesn't necessarily invoke start again, and then we'll just overload the method. So that takes in a player state changer, and it takes in a game object, which is the player. And then we'll just do this dot state changer equals state changer, and this dot player equals player, just in case, because I don't believe that copy will invoke that start method. Okay, and then we basically should have this working. Let's check and see real quick. We'll run the method or run the game, and we get an error. And it says level editor scene cannot be cast to level scene. So what we can do here is, instead of casting it like this, I thought it would return null if it wasn't. We'll just say scene equals that. And then we'll say if scene instance of level scene, which tells us, hey, this is a level scene. Then we'll say scene equals, and then we'll cast it to a level scene. And we'll just leave it like that. And then we'll actually change this to level scene, and we'll just call this level scene. And then we can just copy this and paste that there. So that should take care of that error, and then we can run it now. Like I said, what this is basically doing is we just get the scene as a scene object, then we check and see if it's an instance of level scene, which will tell us if we're in level editor or level scene, and then if it is, then we assign it. If not, we don't assign it. Okay, and then let's add in those portals one more time. We got another error. Let's just add in one more check into here. We'll say if player does not equal null, and we will wrap that guy up just to save ourselves from that pointer exception, which happens in the level editor scene. So we'll go like that, hit save, and we need to implement our serialize method for our portal object. We don't have this part being serialized yet. So let's do that real quick too. Let's go into our box bounds real quick, and we'll copy this guy's serialize method because they are all pretty similar. And then we'll paste it into the portal, and then we will change this to portal and change width to state changer, and change height to player, but we don't really need that, so we won't do player. And we'll just delete all this stuff. So we have the state changer, and then we'll change this to false. We don't need a comma. And we have the portal, and then this is just this dot state changer. So let's see what this says. Let's change this to add int property and see if this works. Okay, let's just do a little bit of math in here because we don't have anything that can change a state changer. So we'll just say int state change. We'll just say int state equals, and then we'll say this dot state changer equals player state dot flying. Since we only have 2 right now, if it's flying, we'll do 1. Otherwise, we'll do a 0, and then we'll just pass in the state. And then when we are deserializing, we'll use this information once again. So this is kind of a hack. I'm going a little bit fast just because I want to get this part done. And it is sort of the last little bit, but this will return a portal too here. There are better ways to do it, and if you take a little bit more time, I would definitely suggest trying to maybe just increasing another add property and then adding in a state changer for that type of property, or creating a serialized method for a state changer, something like along those lines. But for now, this is what we'll do, and this will be good enough for us. Let's check into box bounds one more time, and then for deserialize, we'll just copy this for now, and we'll go back into portal. And then we can just get rid of all this because we know that we just have one property and it's an integer and it's a state, and we will copy state changer and paste it right into there. And this will say consume int property right there. And then what we'll do is we'll just say player state. So player state changer equals, and then we'll say state equals 1. If it does, then the state changer is player state dot, and we said flying is 1, so we'll say player state dot flying. Otherwise, it's player state dot normal. And then we can just pass in a portal here, and we'll just say state changer. And that should be good for our deserialize method. So we have serialization in deserialization, and then one more part that we have to do for deserialization. If we go into file and then parser, and we scroll most of the way to the bottom, we will just add in a case for portal here. So we'll say portal, return portal.deserialize. There we go, and now we should be fully working with serialization and deserialization. So let's try this one more time, and we will add in 2 portals, hit F1 to save, hit F3, and you notice it said portal change when we went through the first one, so that was good, which is exactly what we want to happen. Let's change the second one now real quick. So if we go into our main container, and we just have this going right here, we'll say if I equals 0, which means we're on the first one, we'll do this. Otherwise, we will do obj.addComponent normal. I don't know if this is right too. I can't remember which colors do which in actual Geometry Dash, but we'll just play with this and see what happens. So if we add in one here and one here of 2 different types, hit F1 and then F3, we get a portal change, and then we get another portal change, which is perfect. That's exactly what we want. So now we know that the player state is being successfully changed, because if we go into the portal and into this update method, we can say, oh, okay, so it triggered, and then it said portal change, and we know it got to this line and successfully changed the player's component to the state that we are looking at. So now we can go into the player class, and we can basically change up a few things based on the state that the player is currently in. So right here, we do want to do basically all of this stuff. The only thing we want to change is what image we're drawing depending on the state. So we'll say if state equals player state dot normal, then we will draw this guy. Otherwise, we will draw the flying ship, which I will have a link to in the description. So if you go into your player class, I'm going to paste it into here. If you go to the link in the description and go into the player folder, you'll find this spaceship.png file, and we can load this file in. So we'll go into our init assets inside of level scene. So we'll go right here. Here we go, init asset pool. So right here, we'll say asset pool dot add sprite. Actually, not add sprite, we can just say .get sprite, and then we'll simply just pass in assets /player/spaceship .png. And if you remember, get sprite basically checks and sees if we have it, and if we don't, it creates a new sprite and adds it in for us. So we should be good with everything right there. Then we can go back into our player class knowing that we do have this sprite loaded, and even if we don't, we know it will be created if we need it. So then we'll just say g2.drawImage, and actually let's add this into our player's base class. So we have these sprites, and then we'll add in one more, and this is the spaceship. And then right up here, we'll just say this dot spaceship equals asset pool dot get sprite, and then we'll say assets slash player slash spaceship dot png. So that should be good for the player, and now we have this as a part of him. Let's go down here and we'll say g2.drawImage, and then we'll say spaceship.image, and then we will give it the transform, and we will say null. So this will get the appropriate transform and everything. Right now, it's going to act just like the player object would, but you notice we switched to a spaceship when we have the spaceship, and then we have the player when we have the player. Let's also do this real quick too. So we will also draw the player, and then what we're going to do is we're just going to redo the transform for the player. So we'll go down here. So we're going to draw the spaceship, and then we're going to draw the player, except what we're going to do is we're going to translate the player just a little bit forward and a little bit up. This way we get whatever like the player object is. Yep, and then we'll rotate the player, and then inside scale, we'll just divide the scale by 2, and we'll see how this looks if we even have it. We might want to just divide this by 1.5 because that's probably going to be a little bit better. And what this is going to do is it's just going to draw the player image inside the spaceship, hopefully looking like it's sitting inside the spaceship. And then we'll run this one more time. And you see we got the player there. Let's actually draw the spaceship after we draw the player. And let's divide the player's transform. We'll do this by 2 actually because 1.5 did not seem big enough. And then we're actually going to have to reset so copy all this and then paste it one more time down here. And this is for drawing the spaceship. So we draw the player first, then we draw the spaceship. And we could probably even copy this and paste it in there, but it's fine. It's messy, but it's fine. There we go. And then you saw we had the player sitting just inside the spaceship. He jumps out a little bit because we just need to fix this transform.scale. So we will reposition him, then we'll rotate him, and then we'll scale him. And when we're rotating him, we will rotate him twice around the anchor point since he's twice as small now. And then we will just simply say translate one more time, and then we'll translate him like 10 pixels to the right and 10 pixels up. So let's try this one more time and see if this all works now. Yeah, there we go. It's closer. We need to go a little bit more in the X direction, so we'll do like 15 pixels and a little bit less in the Y direction, so we'll do like 8 pixels. Run this one more time. I forgot Y is backwards. Do 15 pixels. Let's see if this works. Okay, there we go. He's kind of sitting in there. That looks pretty good for me. And he's going to take on whatever rotation he has. So if we go and actually change this up a bit, so we'll have this guy right here and give us a little bit of time before we hit the next portal. So you'll notice that he stays with the spaceship. We will actually change up how the spaceship works, its whole functionality, because that's what we should do. So if we'll go into the player component one more time, we have this add jump force, and now you probably know why I had this as a function and not just as anything else. So basically what we want to do is if state equals, and then we'll do player state dot normal, then we will add the jump force and say on ground is false, and then we'll say else if state equals player state dot flying, we'll say add fly force, and this dot on ground equals false. So then we'll go down here, private void add fly force. And this will just simply do something very similar to this. We might change it and not have it quite as big as that, but we don't need it to be on the ground for the flying force to be applied. So let's actually take this out, and then we'll go down here and we'll say if window.getWindow. Well, actually, we'll first say if player state dot flying equals this dot state. So if we're in this flying state and then they press the spacebar, so we'll say this dot key listener is key pressed, and then we'll say key event dot vk space. So if we're flying and they press space, then we want to add that fly force regardless. And then we'll say this dot on ground equals false. 2. So let's go and do this one more time. And if we go in here, you notice that it's flying, it's rotating way crazy because we also have this little thing that we have to worry about. We'll say else if not this dot state, or actually we'll just say this dot state does not equal state, well, player state dot flying. So we'll only rotate it if it's not flying. And then it's still rotating because of this one up here. So we'll say if we're not flying and we're not on the ground, then we'll do that. And now we should, okay, there we go. So now we get the player flying and bouncing when he's not. So that about covers it for this tutorial though. We have the portals working and the box triggers working. We don't have the player rotating and stuff, but we do have a fully functioning game now. You can play this, you can try it out and build some levels and you should be good. In the next tutorial, what we will probably go over is just some odds and ends that we never got to, and I'll mention some things that you might want to fix and some things you could do to just make it a little bit better. But that covers it for this tutorial. I hope you guys liked it. If you did, please hit like and subscribe, and I'll see you in the next one. Thanks, guys. See you.